Students, so session number 8. Today we are going to study various topics related to chapter 2 units and measurement. Last time we have studied how to deduce the relationship between various physical quantity using dimensional analysis. Today we are going to study what are actual limitations of dimensional analysis, because anything have some limitations. So we have to study the limitations of dimensional analysis. So limitations of dimensional analysis, the first point is the method does not give any information about the dimensionless constant k that we are using after removing proportionality sign k. There is no information about this proportionality constant k. This is the first limitation of this dimensional analysis. Second limitation, moving to second limitation, it fails when a physical quantity depends on more than three physical quantities. If it depends upon more than three physical quantities, then it fails. Third, it fails when a physical quantity is the sum or difference of two or more quantities. Clear? Fourth point for this is it fails to give information regarding T ratios. T ratios means any trigonometric ratios where you will see the dimensional formula fails. It fails to derive relationship which involves trigonometric, logarithmic or exponential functions. Till this clear? Fifth, sometimes it is difficult. The last limitation, sometimes it is difficult to identify the factors on which the physical quantity depends. We cannot identify on which it depends. The method becomes more complicated. When we are having some constants like gravitation constant, Planck constant, etc. The method becomes more complicated when dimensional constant like constants like G, H, etc. are involved. Clear? Moving to the next topic that you have already studied in chemistry, I am repeating the same topic, that is significant figures. Now see, in the measurement, you'll be able to see there are few quantities, or you can say few digits of a number or of measured values. You are sure about that, but there are few terms after decimal which we are not sure about that. There are uncertain digits present in measurements. In case of measurement, we are having certain digits about which you are confident enough, and there are some digits which are uncertain digits for which you are not confident enough. Clear? So that significant, the very first, I want to make it more clear. The significant figures are normally those digits. The significant figures are normally those digits in a measured quantity which are known reliably or about which we have confidence in our measurement and one plus one, you can say plus one additional digit that is uncertain, The larger the number of significance in measurement, the larger the number of significant figures in measurement, the higher is the accuracy of the measurement. The higher is the accuracy of the measurement. Clear? The measurement is more accurate. More accurate means more closer towards its original value. Till this clear? Suppose we can say the time period measured for simple pendulum is about 1.62 seconds. Yes, here digits 1 and 6 are reliable. 1 and 6 are reliable. You can say it's reliable. Whereas digit 2 is uncertain. 2 is uncertain. Till this clear? This digit 2 is uncertain digit. 2 is uncertain digit. And 1 and 6 are reliable digits. Okay. Till this clear? Every measurement 1.62 seconds means what? Here you will be able to see that digit 2 is uncertain, 1 and 6 are certain digits. Hope till this is clear. So period has total how many significant digits? 1, 2 and 3. They have told the reliable digits and one uncertain digit. This total we can consider to be in significant digits. So there are how many significant digits over here? 3 significant digits. Till this clear? I guess, suppose I can give you example, like suppose you are finding the length of an object and is found to be 273.6 centimeter. Clear? Here 273 are reliable, which you are sure about. Reliable digits. Yes or no? And this 6 is what? Uncertain digit. So how many significant digits? 1, 2, 3, 4 non-zero digits are significant. So your total how many significant digits are there? 4. Yes or no? 4 significant digits. Reliable plus 1 additional uncertain. Till this clear? Or you can say figures. Hope till this is clear. Now moving for some rules for determining significant figures. Clear? The very first rule for determining significant figure is all non-zero digits are significant. all non-zero digits are significant. Suppose you are taking an example 13.75. Here all digits are non-zero. How many digits? 1 2 3 4. So how many significant figures? 4 significant figures. 4 significant figures. Till this clear? All non-zero digits are significant. Here there are 4 non-zero digits, 1 3 7 5. So 4 significant figures. Second rule in this you are going to study is all zeros between two non-zero digits. All zeros between two non-zero digits are significant. I can give you example over here. I'm giving you example is like 1300675. Here the zero are between two non-zero significant digits. Yes or no? There are two non-zero digits in which your zeros are lying between. So these zeros are considered to be significant. So total significant digits 1 2 3 4 5 6 7. So there are 7 significant figures. Till this clear? Moving to the third rule for this. All zeros to the right of a non-zero digits. All zeros to the right of a non-zero digit are but to the left of an understood decimal point are not significant. What is the meaning for this? Suppose the example 864000. Double zero, I can give you the example. Here there is no decimal digits, right? You can understood that they have given all zeros to the right of a non-zero digit. This is non-zero digits. These zeros are to the right of this non-zero digits. But we can say that if it's 846000, there is 86,400. We can put decimal over here. Yes or no? But decimal is not given right now. But we can understand that these zeros are to the left of this decimal. Yes or no? And which are right to the non-zero digit 4. Which are right to the non-digit of 4 and which are left to the understood decimal point. We can put decimal over here because we know that this quantity is 86,400. 0.00 also will seem to be 86,400 only. So we can say that the digits towards right of a non-zero digits and left of an understood decimal are non-significant. Means here you can say significant digits only 8, 6 and 4. The zeros are not counted. Because though they are to the right of the non-zero digit, but they are to the left of an understood decimal point, which is not given here, but still it is understood that decimal point can be over here, then only this value can be turned out to be 86,400. Yes, so there are how many significant digits? 3 significant digits. Still this clear? In simple words, I can say that trailing zeros to a non-zero digit, write down trailing zeros to a non-zero digit. Trailing zeros to a non-zero digit, you can say after a non-zero digits are not significant. Till this clear? Moving ahead to the fourth point. All zeros to the right of a non-zero digit, but to the left of a decimal point, are significant. Suppose this same example I can carry forward it over here. Suppose this same example I can put 86400, and if I put decimal over here, this was understood decimal. Now I am giving you with decimal. If I am giving you with decimal, then zeros after this non-zero digit are considered to be significant. Without decimal, no. With decimal, yes. So 1 2 3 4 5. So there are how many significant figures over here? 5 significant figures. Till this clear? Hope it is cleared. Moving ahead to the next rule, that is rule number 5. In the rule number 5, all zeros to the right of a decimal point are significant. All zeros to the right of a decimal point are significant. Example, I can give you 161. How many significant digits? 3 significant. Yes. 161.0 decimal 0 significant 4. 161.00 5. Till this clear? Moving ahead to the sixth rule. All zeros to the right of a decimal point but to the left of a non-zero digit are significant. All zeros to the right of a decimal point but to the left of a non-zero digit are not significant. Suppose I can give you an example. 0.161. All zeros to the right of a decimal point but to the left of a non-zero digit. This is left. It is not concluded in significant digit. Here only how much? 3. Till this clear? Suppose I can give you 0.00161. It is to the left of a non-zero digit, means it is not considered. So answer is how much? 3. Till this clear? Next, that is 7 point. The number of significant figure does not depends upon the number of significant figures. Does not depends upon the system of units. Whether it is MKS, SI does not depend. Suppose I am going to give you example 16.4 meter. It is MKS, yes or no? And still significant figure is 3. If I'll give you 16.4 centimeter, it's CGS. Still significant digits is 3. It does not depends upon what? System of units. Till this clear? Hope all the rules are clear. Now moving ahead, next, that is rules for rounding of a measurement. Rules for rounding of a measurement. Very important. These are all for accurate measurements. Clear? Rules for rounding of a measurement. The very first point over here is if the digit to be dropped is smaller than 5, then the preceding digit is left unchanged. The preceding digit is left unchanged. Clear? Suppose I can give you example. That is 18.35. Suppose I am giving you example of 18.35, and if I ask that up to 3 digits, if I am asking up to 3 digits, then up to 3 digits means 1, 2 and 3. But here it is 5 and it is odd. Here it is 5. If the digit to be dropped is 5, you have to check preceding digit, that is 3, that is odd. Then you have to plus 1 it. So your answer is 18.4. Your answer is 18.4. Till this clear? But here I have mentioned the rule that if the digit, suppose I give you example 18.23, up to 3 digits, I am asking up to 3 digits. 3 digits is 1, 2, 3. The digit to be dropped is 3, which is less than 5. So you have to do not change the preceding digit. Means your answer is how much? 18.2 only. It will not be 18.3 because this digit to be dropped is less than 5. So preceding digit is not going to change. Your answer is 18.2 only. Till this clear? Second, if the digit to be dropped is greater than 5, if the digit to be dropped is greater than 5, is greater than 5, greater than 5, then the preceding digit is increased by, then the preceding digit is increased by 1, is increased by 1. Suppose same example I can give you 18.36. clear, up to I can say 3 digits. So what you will do, you will take first 3 digits, 1 2 3. Clear, done. Now drop digit is 6. 6 is greater than 5. You have to increase 1 to what? Preceding digits. So your answer is how much? 18.4. Your answer is 18.4. If the digit to be dropped is greater than 5, then you have to add 1 to the preceding digit. That is 3 plus 1, that is 4. So answer is 18.4. Third rule, that is, if the digit to be dropped is 5 followed by non-zero digits, then its preceding digit is increased by 1. I can give you example. Example is 18.257. Here I can say up to 3 digits if they are asking, up to 3 digits. Clear? So 1 8 2, 3 digits over. Now digit to be dropped is 5, and it is followed by some non-zero digits, mean it is followed by 7. So here what you have to do, the preceding letter of this 5 you have to increase 1. So for 2 you have to add 1. So the answer is 18.3. Till this clear? The fourth rule over here is, if the digit to be dropped is 5, then preceding digit is left unchanged if it is even. If the digit to be dropped is 5, if the digit to be dropped is 5, then the preceding digit is left unchanged if the digit is even, preceding digit is even. I can give you example of 13.25. if I am giving you the example 13.25 up to 3 digits, 3 digits in 1 3 2 you will remain. Letter to be dropped is 5, digit to be dropped is 5. You have to check the preceding is even, then you have to stop over here, you have to write the same number. So your answer is 13.2 only. You don't have to change the preceding digit of the digit to be dropped 5, because it is even. There are no digits after 5. If there are digits after 5, you have to add 1 without seeing whether it is odd or even. You have just to add 1 if there are certain non-zero digits followed by 5 digit to be dropped. But if it is the last digit is 5 only and that need to be dropped, then you have to check preceding letter whether it is even or odd. If it is even, then same, and if it is odd, then you have to add 1. That is the last rule, rule number 5. If the digit to be dropped is 5, if the digit to be dropped is 5, then the preceding digit is increased by 1, if the digit is odd. I can give the same example over here. If it is 13.35 up to 3 digits, 13.35 up to 3 digits, 1 2 3, I need to drop 5. I will check there are no digits after 5, so I will check preceding digit is odd, so I will add 1. So my answer is 13.4. Hope till this is clear. Fine. Moving ahead, Okay, students, we are moving ahead with arithmetic operation with significant figures. In arithmetic operation, there are two major types of operation. Basically, I can classify into there is addition, subtraction type 1. Addition or subtraction, you can say as type 1. And division or quotient, division or multiplication, division sometimes as quotient, or you can say multiplication. These are the two process considered to be as type B. Clear? In division, quotient, multiplication, or addition, subtraction, in addition, subtraction, you have to remember that we have to take least decimal places. Remember, least decimal places in final result. Key to success, you can say this is key to success. Okay, and here least significant figures, here you have to check least significant figures. Till this clear? In final result, I'll give you one example over here. Suppose I give you example as add 7.21 plus 12.141. what you will do, you will check into the calculator, that is how much 7.21 plus 12.141. 7.21 plus 12.141, that is actually 19.351. Here how many decimal places? 2, means digits after decimal 2. Here digits after decimal 3. Out of 2 or 3, which is least? 2. So your answer should have 2 only. So answer is how much? 19.35. Clear? Moving ahead, if somebody gives you this moving ahead, in the case of division, the first I can give you the example. In multiplication or division, 1.21 into 2.468. Here how many significant figures? 3. Here how many significant figures? 1, 2, 3, 4. Which are the least? 3. So your answer, you have to check 1.21 into 2.468. so your answer is how much? 2.98628. but approx you have to check the correct answer. For that correct answer, you have to check only 3 significant figures, 1, 2, 3. So your answer is how much? 2.98. Till this clear? Any doubt? Sure, no doubt. But you have to check over here the rounded off also. 1, 2, 3 you have did it, but here the number is how much? 6 to be dropped, which is greater than 5. You have to increase 1 over here, so it will be how much? 2.99. please don't write this 2.98. and here you have to check to 19.35. you have to check 2 decimal places, and it's 1 less than 5, so you have to keep it at 19.35. till this clear? Thank you very much.